Hi, this is Eric Wolf, and for my mechanism description, I am going to describe a centrifugal pump. Centrifugal pumps are used to create flow or raise pressure of a liquid. They are one of the main pumps used in industry in many different liquid systems because of their dependability and how effective they are. Their function is to create flow and increase pressure of liquids. I found this diagram and picture on Mega Corporation on the website. It is a very good example of a centrifugal pump. Hooked up to the pump right here would be a motor, usually by a coupler. When the motor is turned on, it spins the shaft, which therefore spins the impeller, which is disc shaped here. Well, when a water source is applied to the inlet and the motor is turned on, the impeller spins the water rapidly and discharges it through the outlet. Because of the water discharging at such a rapid speed, it creates a vacuum at the inlet, which sucks in more water to have the pump spin and discharge it once again. These pumps are used in many different applications. One of the main ones is hydraulic pumps. According to Learn Engineering, centrifugal pumps are the most preferred hydraulic pump used in domestic and the industrial world. They are also used in agriculture, wastewater and water treatment, power generation plants, petroleum, transfer petroleum, and many other different industrial plants for many different applications. There are ways not to run them. They can only pump low viscosity fluids such as light oils and water-like fluids. They should also only be ran at their rated RPM or revolution per minute. You can throttle the discharge by placing a valve on the outlet, but if you close it off too much, you can deadhead the pump, which actually means that the water is not discharging enough and is just getting recirculated in the pump, which causes an extreme amount of heat, which ruins the pump. If you also have enough water coming through the suction, through the inlet, it may cause cavitation, which basically means because there's not enough water, air is getting sucked in as well, and bubbles are formed when the impeller hits it, and these bubbles cavitate the pump, which basically ruins the seals, the impeller, and the pump housing, basically everything in the pump. Centrifugal pumps also need to be primed with liquid before starting. They cannot just be ran up dry. They has to have some water in there for the cycle to begin. The physical characteristics of centrifugal pumps, the outer casing here, outer casing is usually made of cast iron or some different type of metal, but usually cast iron. The impeller is circular shaped, and the shaft goes all the way through. Here's the suction and the outlet or the discharge. These pumps are typically very heavy and very bulky and uncomfortable to carry. But it also all depends on the size of the pump and the model of the pump. They're all different. They also have mounting feet or brackets to secure the pump. Like I said earlier, this is a pump housing. This is a chamber, the volute chamber, where basically it's just the water exits before it gets to the discharge. This is a shaft, the impeller, which spins the water. The shaft is also supported by usually two bearings, which just supports and allows the shaft to spin. These shafts and pumps usually also have a couple different seals, so it blocks the water from not coming out. These seals could usually be a gasket, or mechanical seal, or type of packing. And again, all these do is just block water from coming out. To hold the impeller on the shaft is actually a nut, which just presses the impeller against the housing and the mechanical seal. Like I said, centrifugal pumps are very efficient, but their operation is quite simple. These pumps come in many different sizes and shapes, which all depends on the size of the pump needed for a given application. This makes centrifugal pumps very dependable in many different situations, and which create good flow and good pressure for your needs. Thank you.